So I'm from Coimbra, Portugal, between Lisbon and Porto, the two main cities in Portugal. And our university is one of the first in Europe. And 11 years ago, he won the UNESCO award, not only because it is old, but is this importance across culture and across the world, because it was one of the, for many years, was one of the unique university that spoke Portuguese. Okay, so I will do not a standard presentation with the introduction, state of the art methodology and results definition, but I will give you.
It's not moving on Zoom.
The presentation.
The presentation is not moving on Zoom.
I think we change the
screen that we are sharing.
Change the screen. Yes, it comes now. Comes now.
Okay, but it's not in presentation mode.
Okay. Not in presentation mode. Okay, perhaps like this.
probably.
Contents, yes, change one slide.
Yeah.
Yes,
Okay.
And then we can put it to full screen
Perfect.
here. Should be fine.
this is
Perfect.
Okay, so I was saying I will give you a site for what I am doing since the PhD, more or less, and then I will mix a little bit methodology with the project that I was involved, just to justify the present projects and what we can do in the future. Okay, so I start, and I was motivated by hydraulic jump, that I think that is the hydraulic phenomena most interesting in the world. And it's really important to, because it can have hydrodynamic pressure and cavitation in the bottom, and could even move slabs very wide in the bottom of the sealing basins. So I start to do a numerical simulation of hydraulic jump, also with the experimental physics. And in that time, I used the NASA VOF 2D, that was one of, that was public in Los Alamos. And I had to model all the high order schemes for velocity, and I could model the hydraulic jump with the apparently realistic way. But when I compared the results with the literature, and when I did some calculation along the hydraulic jump, I didn't have the velocity very accuracy, because we still have a lot of high velocity in the bottom, and also we don't have the energy dissipation that we were expecting in house models. I also used this model for step spillways, but then Pedro, that was one of my first students for PhD, he wanted to go further in solving the hydraulic jump, and he tried to include a subgrid model for air entrainment in the step spillway. So he could note that for narrow spillways, we have like a 2D model, but when we enlarge the width, we have like cross vortice along the width. And with the air entrainment model that was implemented in OpenFOAM, air interfoam, it could go with better results for the water depth. That is one of the important things to analyze for the walls of the hydraulic structures. So the model, it starts with the VOF model, and then we can analyze where is the interface, okay, with the VOF function. And to include the subgrid model, we select just the interface, and then we calculate a source term given by turbulence or velocity normal to the surface, and we could include some bubbles inside the model. Okay, we can couple one-way coupling or two-way coupling, okay, with some interaction between air and the model. Okay, here we did some simulation in the gully. Okay, in that time was much easier to have to be funded in urban structures. So we dedicated for the gullies, and we could have some depth and some insight in the model. Okay, we also have like some geyser when we have a lot of flow there. Okay, as you noted here, we didn't have bubbles inside, so use the air interphone to analyze the role of the bubbles inside, and we got good results as well in the gully. Okay, then NASMO start to include sediments, like just a transport equation, and use some literature models to calculate like the sediments in the manhole with the velocities with different water depth. And it has to analyze some pollutants passing through the surface in the streets and also in the manhole. And we got quite good results. But my main issue was the pressure on the bottom. So recently we applied different models in the jet, also with the models from EPFL. And with this model, we apply open foam with different conditions. We cannot just the slides because we have the outlet. So, but the quarter we have like symmetry condition. So we use both subgrid model and multi-phase foam. Okay, this is just velocity. With this we distinguish here the water and the air. Okay, so most part of this velocity belongs to the air and not with the water. Okay, so multi-phase foam is taking too long to be solved, but it seems more realistic. But in the end, as we need too much time to have average and to have water depth, we can use VOF or subgrid that we took into account some air. Okay. We analyze the steady state and we compare different models for the pressure on the bottom. Okay, we got good results from the fluctuation because we had turbulent kinetic energy according with the fluctuation that is according to us. So turbulent kinetic energy is 16. So the square is 4 meters per second, and it is according with the experimental in FSL. So I would like very much to study blocks on the coastal infrastructures, and we can see in Spain here there are blocks that are broken, and also in Nazaré in Portugal, where you use tetraples, we can find some broken. You see here, and this is subject to the very turbulent flow. Okay, now we are analyzing with drones the port of Sinj, and we see there are some movement in the blocks, and we could compare these figures to characterize the movements in the blocks, and then we can use also to validate some models. We have a research center in Figueira da Foz, that is Mare Foz, and we can also have access to this breakwater. Of course, I'm worried also about the sediment, the erosion near the beaches. Mainly in Figueira, that we have a problem that we have more creation here and erosion here. And the prediction are to have these lines, and we are testing like some low sediment flow from this part, north part to the south part to but it's very expensive, so we are looking what is the best solution. And I also worried about some projects in the urban part, in rivers, because the new projects for Coimbra are including some lateral cavity in the river, and this can accumulate dust. And we work also in our research center with the pollution and microplastic, and we see in Figueira that appear a lot of dust. And we also analyze a lot of things related with the aquatic system and the quality of the water. So looking of the problems that hydraulic is involved, we have a lot of problems, and we have to dedicate a lot of things related with the water. So my motivation is more and more related with the fluid mechanics to understand how the flow behaves with different hydraulic structures. So I like it very much when I saw a picture from Nakaku and Netema that gave an overview of a river with the engineer problems on one side, and the other side is the theoreticals to understand it. So I adapt a little bit. So I have here the engineer problems related with hydraulics, here the theoretical phenomena that we have to understand, and here the variables that we have to calculate. I also have another layer when I teach laboratory techniques, that is the equipment that measure this. Okay, but I was not. So this involves a lot of things, from rain to drainage to urban part, some natural cavity, some interaction with vegetation, and so on. So I think that the picture talks that. Okay, so focus on fluid mechanics, the water. If the velocity is great, when you have some geometry change, we have some movement in the water that create some process. We can understand turbulence nowadays with the energy cascade, that the energy is spreading from large scales to smaller and smaller, and have some dissipation. And we also know that there are a lot of dynamics that are characterized by different Reynolds numbers, and we can now simulate and model and understand these particulars. The CFD we can apply with the meshes thinner and thinner, and for this kind of mesh we can use large eddy simulation instead of runs. Nowadays we saw a lot of publication that says that is large eddy simulation. It is not real large eddy simulation, because for having large eddy simulation we need to have a very fine mesh. Also we have multi-phase ultrasound that we can see, that is the only model that we see some interaction between the air, and this we can see very easily when we have a wave break, that there is a spread in the air and in the flow. Okay, so here is the velocity, here is the different flow that I also include some sediment in the bottom to see some erosion. Okay, so I'm motivating now to calculate the air entrainment and air water. And this is similar to waves and to jets. We can identify from fluid dynamics the different types of air entrainment we have. And also the turbulence that could also provoke some structures movements, and that's I would like very much to study. Okay, about the air entrainment models, we have, and I presented the multi-phase Euler form, that is the Navier-Stokes equation for each flow. Then I also use both, that is the one step from Navier-Stokes for the whole fluid, like a mix between water and air, that could be include water and air just with the density and with the viscosity. And we can also use the subgrid model, that we have an additional equation for the gas with a source term that could arise from excess of turbulence or of velocity normal to the surface. And there is ELSA model that mix also with Lagrange, that is able to simulate some bubbles and some interaction, some evaporation interaction from the water and air. So I'm moving now to Rouen, where they developed this model to analyze this kind of model in some different problems. Okay, let's move with the methods that I will show with some project we did. So after finishing my PhD, we did move for a new labor, because now university is divided between Polo 1, that is the old part, the Polo 2 is all engineers, and Polo 3, that is health science. And I had just the flow without energy. So we took some model, some simulation about the landslides. We didn't need any current, just water inside. Okay, and then we had a project to equip all of this, and I was in charge to do a SCADA system for able to connect or switch on a pump, 2, 3, or 4 pumps, and control the flow between the reservoir, the 2 reservoirs and the channel. Okay, we did a lot of tests, like some new equipment for producing energy, some hydraulic structures like channels with baffles, and we start to develop some image techniques. And this was in MATLAB. It was a master student that didn't like very much to study, but he liked very much to photograph cameras and so on. So he did a Simulink with doing a video, and at the same time we can calculate the water depth instantaneously. So it's kind of easy task. We pass water and the water and air, and then we can have some edge, and then we can calculate the distance from 2 points. Okay, we improved this model recently with different bottom in different channels, and also motivated by image, we follow some techniques in MATLAB to analyze the movement of the blocks. We collaborate with LENEC because they have a lot of laboratories with big space to have breakwaters, and we analyze with just a simple technique like a matrix, subtracting every matrix. So we have a film, we split in several images, and we subtract each, and then we can analyze here where there are big slopes. And here we detect the image before and after we have this. So we notice that one of these stone moves to here. So with this technique, we can localize in time. And then looking at the matrix, we can localize in space. And then if we want we can spread with different blocks, different colors, to have like different groups and distinguishing different colors. And we also can define the edge to analyze better the problem. Okay, we also detect some overall movement because the storms were more or less like that, but with that difference, we had a movement altogether the blocks, so we could analyze also this. Okay, for air entrainment, we also tried to find a relation between air and water. So we cover with black backgrounds, but then we have water and air, and it was not very good. So we have to change this part to white for having the right relation between water and air. We applied to hydraulic jumps and to step spillways, and we had some publication on that. Okay. And then with the project Quicks, we use the PIV to compare with the CFD. Okay, with the projects related to urban structures, we could extend our installation to a dual drainage or multi-link models, and we have like a channel, a flume, with two gullies connected to two manholes, and then we extend also the SCADA, and we develop also some possibility to move the valves to have a water inflow, like a hydrograph, like a variable inlet in the installation. So we could do like we give this, and we took more or less the same. Okay. So is this installation, sorry, I do the eye, but this is the manholes when we have acrylic to see the water inside, and we have that flume, and that's the pipe between manholes. Okay, so we can do this. We have a lot of pressure to analyze the pressure when we close the valve suddenly, and we can simulate also to have this problem. The other project I was not involved, but I was very interested. It was to analyze with drones to identify different kind of litter in the beach. Okay, this is the same technique we use also in hydraulic structures to have the correct geometry or to verify the geometry. Okay, so with this project FOSTUA, we were allowed to measure in the Stilling Basin in the north of Portugal, but we didn't have the right geometry, so we use also drones to calculate the surface. But the surface has a lot of irregularities and is not very good to use in numerical models because we have a very complex mesh. But we have the scale model in Linné with the drone. You see, this is an image. We see here a reflection in the bottom, and we can place in GIS the models. Okay, the project includes the place of velocity transducers and pressure transducers. And so we construct some box in inox to include a new velocity that is able to calculate the velocity near the bottom. But the problem is that theoretical, the velocity near a wall is 0. So at least I would like to know what is the direction. So the only thing we could have from the EDP, that is the electricity of Portugal, we can just have like a millimeter or 2 millimeters and not a case. And then we have to calibrate with a jet to know where is the direction. because in the end, we just turned, we placed the box and we didn't know where was the reference. So with the jets, we knew and we could have the velocity, because the problem is when we have the jets inside the pool, we have a lot of vortices and we never know what happens. So the structural engineer just put concrete for the dam to be safe. Okay, but like with the draws and with the doing blueprints with the image, we could have a structure that we could use for the scale laboratory, we could use for open foam. And we can have different image like the bottom outlet or the spillway over the dam, and we can have access to the pressure in the bottom and the instabilities, fluctuation, and so on. Okay, with the drones, we tried also to do some inspection periodically in breakwaters in Portugal. We have some of Nazaré, some of Figueira, and since we will have frequent. Okay, so here Nazaré is a mix of tetraples with the stones. We have others that are anti-fair, and we can use image techniques to detect movement in the labor. So if we can use in the labor, we can apply the same technology for the real breakwaters. I prepared already some proposals, but it's not very easy to be funded on this. Okay. Other project that we were involved was placing like we call the smart stones, that like is a gyroscope in the stone in the breakwater, and we analyze different image to see if it fits with the movement of the blocks. And I tried also because this is a very large wave basin in Hanover with the 70 paddles, and with the spectrum we could have inlet, and translating the movement that they had in the wave basin, we could reproduce waves on different directions. And then we can analyze to see the statistics and so on. Recently with a master student that after doing all the work, he disappears. So we just need for him to write. We analyze the overflow and the run-up in the structures in Lanek. So we use also image analysis, like do some work on image to have more contrast, and then we can include like just a frame to see the distance from a point to other point. Okay, and then if we have like several windows, we can have different heights on different times, so we can have like with a spline the run up and calculate the volume. The idea was that. Okay, so we have here for you, have a look what's happened with the run up and overflow, and we try to do this with open foam using a turbulent model appropriate. Okay, and we have like this. Okay, this geometry is like this because we need all the model, and so this scale is distorted. Okay. So in our labor in Coimbra, we have the dual drainage model. We have a lot of flumes with the sediments, and we use our dual drainage model to place some cavity here to analyze like different dispersion of this. We try to use like low cost laser, but still not working. So you cannot see, but we have not so much illumination, so the seeding is not very known. but it was just to see if we could have large area simulation. Okay, and here now we have a commercial PID, and we are doing this work to analyze the vortice inside the cavity. It depends from the dimension and depends from the velocity. And we also are using the EST that is in Lisbon, the cavity, more natural cavity to analyze the dust in rivers. This is also part of the project HESPER that we are developing mathematical models with GPU, with high performance computing to analyze different kinds of models. And for this HESPER, we also use depth channel to analyze different dispersion on different rough bed. Okay, and we have, when we have rough, we have less spread. Okay, for this we validate some image with the different concentration, and then we compare each pixel with the examples, and now we can calculate the concentration. Okay, the other project that we are collaborating with Dublin is Data, and we start for having a platform to know the variables along the Atlantic, and then we can focus in important places. And here the platform is looking at Figueira da Foz, where we have some aquaculture, and the aquaculture is more or less here. That is the mouth of Mondego, the river that passes in Coimbra and ends in Figueira da Foz, and there is a lot of tanks where there are sea bass developing, and we have to analyze the performance of the aerators to see if we are losing a lot of energy or lose money, and we don't need such an oxygen. But the producer prefers to spend money on energy than on fishes, because the losses are huge. So the proposal is to contribute to a better monitoring of aquaculture farms and optimize some problems of energy with air and calculate the mass. So we are still in the beginning. The project starts now. So for this, I also use image to construct the paddle, because I contact the producer in Taiwan and there is no draws. So we try to develop. Okay, with image we don't have very good image, but even with the paddle we could construct new, and it's better to have the dimension, so it helps. Okay, and so we have a kind of movement here, and we did like a simulation with different velocity, different mesh, with a paper published to see if it works. And now we are analyzing the results of air inside the water to calculate the dissolved oxygen and to relate with the food spreading and so on. Okay. So to conclude, I think that I see all this always civil engineer like helping the people and the environment to be resilient to the new actions. So I think that we must continue to monitorize, to do some image analysis, because easy, and we know what we can have from the image. Of course, we have to develop a lot of tools to analyze the data and to analyze the image, to have the more we can from the data. And I took a diagram from United States. They think that they can have a computational tool that connect the computational fluid dynamics with the fish behavior and have an idea also for aquaculture. Okay, I'm now focused on developing my my abilities to model better air entrainment. And I would like also to, in the future, to go through the multi-body dynamics to know how the blocks move and how we can help like the coastal engineer to be resilient to the climate change. Okay, thank you.
Hey,